Hello, in this video we will be talking about your mnemonics, your family seed, and also about plain passphrases. So what we will be clearing up here now is how does all of that actually work. So we've got basically our mnemonic or whatever. So we, for example, let's just take any mnemonic. For example, we've got whatever castle, I don't know, bone, arrow, I don't know, whatever. So like these 12 to 24 words, so 12, 16 or 24 words. So either the mnemonic or also the other thing I showed you in another video was the so-called family seed. And we will now looking over how all of that actually works with signing transactions. So I will be citing or more or less going over with you about an article, so published on XP Community blog, and on this website, this article was again also made by Wind, and we'll be going over it with you and also breaking some things down. So it's very important, obviously, we have to keep the mnemonic safe. So that is your master key, more or less, and you should obviously never tell these 12, 16, or 24s anybody, because if you do, they have full access to your account. So we've got all of that, and also so regarding the terminology, so calling in an account something that starts, so an account is active on the Excel ledger when active with depositing whatever. So it's more about an account is basically an address on the Excel ledger. So we're just highlighting here just any address on the Excel ledger. For example, just go to one transaction and go to any address we have here. So this, for example, is one a account. So we've got that thing here is an account, and that is the account address. And also when we refer to, so when he's referring to a wallet, he's talking about software. So basically a program which basically understands how to derive all the info from the mnemonic. So let's go on. So basically the first thing is whenever interacting with the XML ledger, so meaning if when you interact with a node which is running a RippleD server, you're sending JSON information. So JSON stands for JavaScript object notation, and it is basically a simple way to describe data. So it's also human readable, as you can see here. So for example, there is certain fields the XML ledger expects from us, and we set, for example, a transaction type to a payment. So we've got, for example, as I mentioned before, multiple transaction types, for example, also create offer and so on. Then we can say which account we are. We add our account address, and that, so we don't do that. That's all of that happens automatically. And then we have a destination. So where it's being sent from, where will it go to? Then the amount expressed in drops. So we've got your 1 million, that's 1 XRP, and the fee also in drops. So 12 millions of an XRP is the fee here. So we've got the entire thing here, and then, well, then we have to sign this transaction here. So like I said, we've got that thing here, and then we can see here how did all the RippleD servers and validators know the transaction was really yours to make. Couldn't you have, okay, so couldn't you have changed it? Like, for example, if you just add the account address of Binance, and no, obviously not, because you need to sign a transaction and submit the signed transaction to RippleD node. So let's go on. So signing your transaction means we'll have to prove you're allowed to spend funds for the account sending a transaction. That's what your secret or mnemonic is for. Okay, so we will talk about this any second. So we will go on. The signature contains a blueprint of the document you're putting it under. And also, right, let's go on here. So to create a signature, we need our hexadecimal private key. Using that one, we encrypt and sign our message. But the thing here is, for example, we can look at that here. We've got here an example of a hexadecimal private key. And from the private key, we can derive our public key. And from the public key, we can derive an account address. So using the Ripple lib but that happens automatically, so we will be later looking over it. So you probably don't know your own key pair. So yes, you don't know the private and public key. These are these two ones here, for example. You don't know them, know all of those things that happens automatically. And not directly, your hexadecimal private key is derived from a secret you do know, and your account address is derived from a hexadecimal public key. So now let's go over what happens when you sign a transaction using software. So you could whatever you have, for example, using the Expo Ledger or using a website to sign a transaction, or also your phone or anything basically, where you run software that knows how to do that. You basically have a transaction message. This is in our case that thing here. So this JSON object where we will tell the RippleD node what do we want it to do. That's the transaction message. Then we have our private key. That's the thing the program knows itself, so it's being derived. And we obviously we don't know that, but the program does know it when it has our mnemonic, it can derive all of that. And we've got also public key. So first we take the transaction message, hash it. So the first thing we have to clear up here is what is a hash function, or what is a hash. So basically a hash is a text. So so basically it's more or less, we could call it a filter. So we've got like endless possibilities. So the text could be of length whatever we'd want to. Well, let's show 256 online. Let's use that one here. We've got unlimited possibilities, but whenever we change a word, we've got limited output here. And as we can see here with SHA-256, we've got the length is always the same. It consists of A to Z and numbers. And whenever I enter something, it's being hashed. The idea behind this is that we can't go back though. So if we just have the hash, we'll never know what the original text was. So that is called a hashing function. So we take our transaction we've got here and we hash it. So I will just do it for like quick purposes of like showing it off. So if it here, for example, it doesn't matter what I enter here. I just want to show it similarly. For example, we've got payment and so on, so on, so on, and then we've got our hash here. And so that's the hash here. And then we basically sign, or more or less encrypt, our hash with our private key. We encrypted our hash we generated here. And then we will go on. And also we will append to the message, so our package now contains three things. So we've got the transaction message, meaning that we will have added like this entire thing I just showed you. So let's just go on one more time. So we've got that part here. That's the first part, so the transaction message. We've got here. Then the second part we've got here is the signature. Oh, my bad, sorry, I'm up here. So we've got first the transaction message, then we got the hash and signed it, so we encrypted it. So we took that hash here and we also encrypted it so it looks differently again. So nobody can tamper with it on the way. So this looks so I will put parentheses on it. I will add encrypted, so that's the encrypted part here. So let's add it in red. And I know it's not the most, it's not like the best, but whatever. So I'm just trying to make it a little clearer. And then the last part we add is our public key. So the public key, anybody can know our public key. That doesn't matter. So we will add also our public key. Okay. So these are the three parts we added here. And this is being sent to the RippleD server. When the RippleD server receives our transaction, so our transaction, then it takes a transaction message, and so all this entire thing is being sent to the RippleD server. So it's being it's being described here as RippleD, and we've got a transaction message, and now it's being hashed on the Expo ledger itself again. So it takes the entire thing here, this thing here again, hashes it, and compares it when we take our signature, we decrypt our message with our public key, so the RippleD decrypts your signature, so it gets the hash back again, so the hash from before, and then compares if these two are the same. So if now this hash, so this was before encrypted, so this look differently again, and it gets decrypted using our public key. So using the public key, this turns again back to some other stuff, and then then we've got here this hash, so it's basically from the encrypted. The RippleD server takes it, and then it gets transformed into the normal version of this hash. So it's not encrypted anymore. No, so normal / not encrypted anymore. Okay. So, and to decrypt it, it used our public key. It used our public key. So this public key was used to decrypt it. That's how you decrypt stuff. And then the RippleD server also takes the normal transaction, so the plain text JSON object, and also hashes it with the same function. So it gets hashed again, and then we get a hash again. So so it's basically hashing, and then we have to get the same. We have to get the same hash. If these two match, then the RippleD server knows it's us. Oh, basically, it's a somebody who's allowed to send it. But if these two hashes are not the same, then the RippleD server will say, nope, I will not allow this transaction, and it gets declined. So that's being here shown. So if those two are not equal, so if they are equal, then it says, okay, that's fine. Otherwise, the signature doesn't match, transaction hash, contents change, so somebody, or isn't signature doesn't match, so, or signature doesn't match, public key for private key. So one of these things fails, and then the RippleD server says, nope, you're not allowed, so I won't do anything. And that's basically how it works. So one thing we'll also be looking over is that thing here. So we've got here the plain passphrase, we've got an account secret, and the mnemonic. And the part here is that from the mnemonic looks something like this, as we can see here, novel matter, so some words, just basically the secret. I showed you one of those before, but I could quickly generate one. There's a website to do that. So also we'll quickly look it up though. So there's a website called Paper Account. So here we can just generate our own XML ledger account, basically using just giving random input and creating a unique pattern. So we get our own account secret. So now it's almost done, and here we go. I think not quite yet, but now, right. And now we've got here the family seed. That's how the family seed looks. Okay. And from this family seed, so we've got here the family seed, and also from the family seed we get the key pair. So we can from the family seed we can derive a key pair or multiple key pairs. And the same goes for also the mnemonic. Oh, by the way, I will have to correct. Sorry, my bad. I meant from the family seed we can only, I think, get one account, so we can only derive the key pair. But also you're able to derive multiple from the mnemonic, as far as I'm concerned. So I hope I'm not. So correct me if I'm wrong. But right. So then we derive a key pair, meaning that we generate from that family seed, we get a private and a public key. So the hexadecimal private and public key. Using the public key, so using the hexadecimal public key, we can generate the account address. And also something I mentioned down there, everything's one way. So going from the mnemonic to the seed buffer, you can't go back from the seed buffer to the mnemonic. Going from the seed buffer to the derived path, so going to private and public key, we can't go back to the mnemonic, and we also can't go back to the family seed. So so parentheses like secret key, as we can see here. So, right, so that's basically the gist. I hope I was able to explain it well, that you were able to understand like a little bit how the entire signature process works. I will also be linking this article here. It is very nicely done, and well, see you in the next video.